Okay, today we are wrapping up this really short little unit on chapter 7. And what you see on the board here is just the CAN lab, or at least part of the CAN lab here, where today we took data. And basically, I'm having kids fill out this chart. This is the height, which, again, you just measure, divided by the radius, which you just measured. And then, in this case, would somebody just use your calculator quick and type in 85 divided by 24? Whoever's fastest, tell me what you get. 3.541? All right. Now, there will be a certain height to radius ratio, which is ideal. And maybe none of the cans that you measured will be that can. What you need to figure out is like what kinds of ratios seem to work best. In other words, is it tall and skinny? Is it short and fat? Is it really low cans that have very short heights? Anyway, the actual surface area of this can, I do not want you to like measure it with little squares or anything. I want you to just calculate it. So who knows the formula for the surface area of a can? 2 pi r squared is good because it's got 2 circles on it, top and bottom. So 2 pi r squared. You know the rest? Plus 2 pi r. 2 pi r because that's the circumference. Good. Times the height. Excellent. I want you to picture that for just a moment. That's like if we cut this can open and we took off its top and its bottom, the rectangle you'd have left and like scrolled it all the way open. This area here came from this circle on the top. So it's the circumference, which is 2 pi r. And then this height would give you the whole rest of the rectangle, 2 pi r h. All right, so that's the surface area. That formula is important. If you haven't already written it down, write it down. And then how about the volume formula? I would expect you to know this. Like, this is something, for instance, on the ACT that you need to know, and they don't tell you. You either have it memorized or you don't. Does anybody have the volume formula for a cylinder memorized? Yeah, space times height, but for a cylinder, that's what? Pi r squared times height. Excellent. Okay. Now, between that and knowing that your can that your company sells needs to hold 1,000 millimeters, gives you all the info you need. If you know this thing needs to hold 1,000, you have all the info you need between this and this, and knowing that the volume is 1,000. You can figure out the rest. I'll just tell you what to do. They take a while. They make you like figure out, okay, what am I trying to find here anyway? What is my goal? What am I trying to do? I'm trying to get somehow the radius related to the height. All right. So a graphing calculator is certainly allowed. It could help. And just for one thing, at minimum, this is the easy part. Just fill out this whole chart. Somebody might ask, what's that last column for? Well, really what you're trying to do is maximize the amount of volume you have for how much surface area you used. So I would make this the volume divided by the surface area ratio. Whatever's got the best number there, the most volume for the surface area of your can, that was your best can out of your 5. And then you just have to look at the dimensions of it and go, oh, okay, well, it doesn't look like it's this kind of can. Looks like it's more like that kind of can. And I will tell you that it is not a typical soup can. Everybody thinks it is because, like, you see more of these than anything else. It's not. All right. You'll have to figure that out. So that last column is V over SA. You got 2 formulas written down. Hopefully you got that all done by now because I'm about to move on. All right. Next, let's talk through today's stuff. So this is the new one for today. It's 7.3 day 2. And really there's only one new thing to talk about, and that is inversely proportional versus just proportional, or directly proportional. So I'd like you to actually scroll down a little further. This is old homework. Oh, just a quick reminder here. You were responsible for those word problems for today. So hopefully you've already got those word problems from the last homework assignment done. And there are answers you could have checked. All right, but here is the new stuff. Varies directly or varies inversely. Y equals kx is an example of two things that vary directly, and k over x is an example of a kind that varies inversely. Let me show you a situation. I think you'll understand it better if I use some variables from the real world. Would you agree that if I light a stick of dynamite, leave it on the ground, it'll blow a hole in the ground? If you don't know how powerful dynamite is, it would definitely blow a hole in the ground, okay? Do you get if I put 2 sticks of dynamite out, it's going to blow up an even bigger hole? Does that make sense? All right. So that one, does that vary directly or inversely? Directly. The more I do, the bigger the hole. But inversely. Here's an example of something that varies inversely. I feed my cat more. I give the cat, a real small meal. It still has hunger, but it has less hunger than it had at the beginning, right? I added food to the situation, and it got less hungry. If I add a lot of food, it gets even more small. So how hungry you are compared to how much food you have in front of you, and the food you've actually eaten, as you add more food, how hungry you are goes down. Does that make sense? All right. So you can always make exceptions. There are foods you can eat that actually make you more hungry. There are foods that you can eat that make you more hungry. In fact, they're considered an appetite stimulant. You can look it up if you want to. That doesn't go on forever, though. Like at some point, like apples are, for instance, something that's supposed to be an appetite stimulant. So if you eat like 72 apples, do you think you're really, really hungry? No, it doesn't really work that way. But if you have a slice of apple, for example, it doesn't actually make you feel really full. It actually makes you feel a little bit more hungry. So anyway, there's all kinds of exceptions to the rule, but can you think of something else that would be an inverse relationship? The more you do, the less it does? Yes. All right. Okay. So, but likeliness to fail. Okay, probability of failing. Okay, I can buy that. Okay, so the probability of failing and homework. Done. We'll call it H. We'll call it P. Would you write me an equation that has H and P and K in it? K is the constant. We don't know exactly the ratio, but it's got to be true. The more homework problems you do to practice, the lower your probability of failing the test. So for example, if you did this, H equals P times K, you missed the point. Because what that does is the more probability that you have, the higher amount of homework that you do. It's not exactly it. What if I switch them around? P here and H here. Still not good. Because if you increase the H, do you get that the P will get bigger? The more homework you do, the higher your probability of failing. That's not good. So what should it have been? Nope. Over. K over H. Now think about this. When h gets to be a big number, do you get that this overall is going to get small? You get a high amount of homework. It's dividing by a big number. That's going to make it really small. More and more this is, smaller. Sorry, the bigger the h is that you put in, the smaller this probability will be. And that's inversely proportional. So basically, your two variables go here and here if it's inversely. What if it's directly? If this had been a direct one, oops, not over, then if it had been direct, it'd be k times h. And your two variables go here. Messed something up. There we go. Here's your two variables. And you always have a k in your answer. All right, so let's do one more. Let's see if this one makes sense to you. The way you can tell if a hardwood floor is really hard is they actually take a marble or a ball bearing, okay, and they set it on the wood. They do this not on a finished floor. They do it, in the lab. They have one piece of the wood. They set the marble on top of it, or the ball bearing, and then they press on the ball bearing. Now, do you get if you press hard enough, the ball bearing is going to squish into the wood? Okay, no matter how hard the wood is. But do you get a really soft wood? Doesn't take much pressure. You don't have to push very hard, and then that's going to leave a dent in your hardwood floor. Do you think people like dents in their hardwood floor? No, nobody likes dents. So they all want hard wood. And so the hardest woods are like pecan, walnut, and some of the exotic woods like tiger wood. And one of the hardest of them all is bamboo. Bamboo is extremely hard, especially at least in the type for flooring. If you ask anybody in the flooring section, they'll say, oh, that bamboo stuff's really hard. Okay, so the amount you press down, okay, on the ball bearing, we call that A, amount of pressure, and D, the depth of the gouge in the floor. Would you write me an equation for those two that shows that you understand whether it's proportional or inversely proportional? Turn it my way and I'll tell you. I'll pause while I check these. Okay, so this one was A equals D times K, or K times D. That does not matter. All right. How about this? Something that's inversely proportional. How much you spend and how much you brag about how cheap your floor was. Do you get if you only spent like $500 to do your whole hardwood floor, you're gonna be like, and it was only 500 bucks. You're gonna be bragging about how it was really cheap, okay? And if you spent like $100,000 on this amazing floor, you're probably not gonna brag about how cheap it was, right? So write me a formula that would be price of floor related to B for bragging about the value you got. Let me think for a second. Yes, that's it. Yep. Everybody's getting it again. I get the feeling you all understand this by now. So the price could go underneath the K, and as the price gets to be really big, this overall gets to be really small because you aren't going to brag very much when you paid a lot of money. Yes? Gotcha. Well, actually, oftentimes you could reverse them. So it's just a matter of what they ask for. If they say in terms of, then that's got to be on this side. If they say in terms, let me write this out, of P. If they want it in terms of P, then the P has to be with the K on the right-hand side of the equation. Okay, so if I said I want bragging in terms of price. All right, good enough. I think you got that. And there's only a few questions on that tonight. So let's do a little bit of review right now. So here is a word problem. And I'm going to see if you can translate this into both a sketch and then an equation and then actually a final answer without your calculator. Because the test won't allow calculators, and I made the numbers on this nice enough, so it's definitely doable. All right. So actually, I'm going to do a rate one first. You ready? This is going to be a turkey eating deal. So let's say that I eat 3 pounds of turkey over, I have trouble writing turkey apparently. I'm going to try that again. In 2 hours. My brother Mick is a little more conservative. He eats 2 pounds of turkey in 1.5 hours. The question would be, if we had a 6-pound turkey, how long would it take us to finish it off? Set that one up. I'll pause for a minute while you try that. Okay, so you should have said for this part, 3 pounds of turkey in 2 hours. You write a rate. And the rate is 3LB over 2H. Plus the other rate, 2LB over 1.5H. And I'll probably change that to 3 over 2 to make it easier to work with. Equals the total rate. Well, what's the total rate? Well, I could just put X and find our total rate. But it'd be smarter to say 6 pound goes on top over X. Now, you could have done it a different way where you just set it equal to X and solve. But then you'd have to do a new problem to figure out the 6. All right, so there's your setup. Raise your hand if you set that up right. Okay, good. Now, you know what to do? I personally would change this to 3 over 2. Actually, let me back up a notch here. Let me clear that out. Now I'll change this to 3 over 2. Whoa. Undo. What? Why is it doing that? Okay, fine. I'll go like this. 3 over 2. Okay, so now I'm going to multiply everything by 2 and 3 over 2. But look what cool thing happens when I multiply 2 and 3 over 2. It's just the 2 and the bottom cancel. It just turns into a 3. But anyway, 2 and 3 over 2 and 2 and 3 over 2. All right. And, oh, and there's an X on the bottom. Got to times everything by an X. So this cancels this. 3 over 2 cancels 3 over 2. And 2 cancels 2. And I have 9 over 2, or 4.5x. Now this term, plus 4x equals 18. And from there, it's 8.5x equals 18. Divide by 8.5. Divide by 8.5. And you have 18 over 8.5, approximately 18 over 9, which is approximately 2 hours. But the denominator is a little smaller than that, which means it's a little more than 2 hours. got an answer of a little more than 2 hours. I'm doing it right. Questions on that? Yes. So let's see. It sounds like that fraction equals the same thing as 18 over 8.5. If it does, then you're good. Okay. Next problem I want to give you. How many got that one right, by the way? How many of you had it right? Ooh, not many. That's scary. So let's do one more rate one then. All right, let's say this is my rate of picking up the parking lot. I've seen a guy out sweeping in the parking lot at this local restaurant. Just sweeps to, you know, he's hired by the company, he's wearing their little logo and stuff. So he's out there just cleaning up the parking lot. Let's say that there's one guy who's really good at it, he's just super efficient, and he gets it done really fast, okay? And that's Mark. And he can do it at 500 square feet in 10 minutes. Raymond can do 20 square feet in 3 minutes. Much slower. The question would be, how long would it take them together to do a 1,000 square foot parking lot together? I'll pause for a second to set that one up. All right, so let's just check so I don't have to wait quite as long. See if you set it up right. Should have just done a rate plus a rate equals a rate. 500 over 10, and that's square feet in minutes, plus another rate, 20 square feet 3 equals the total rate. But I don't really want to go figure out the total rate and then to go have to do a whole separate math problem. It'd be smart right here to plug in the 1,000 square feet right on the top. And then put X, and it'll figure out how much time we will need together, these two guys would need together, to get a 1,000 square foot parking lot done. Raise your hand if you set that up properly. Good. From there, you would multiply by 3 and 10 and X to get the X out of the denominator down there. 3, 10, X. 3, 10, X. 3, 10, X. X cancels here, X cancels here. This becomes 30,000. The 10 cancels here and 10 cancels here, becomes 3x times 500, sorry. 3x times 500 is 1,500x. And this 3 would cancel this 3, and I'd have 10 times 20 is 200x. Making a total of, again, 30,000. And then I would just make it 1,700x. It's 30,000 divided by 1,700. But, again, I get that that's a weird decimal. So, all right, it's the setup that I'm mainly concerned with you being able to do. All right, now here's a setup problem. Imagine a package that looks kind of like this. And usually do length on the longest side, width goes across, and the height has to be up and down. And now that you maybe see the rest of the box, you can kind of get the idea here of what this thing's supposed to look like. And now I'm going to have a wrapper, a blue bow going around this package. It comes back up the other side, and then like here's where the bow would be. But anyway, that ribbon that goes around the whole package, it doesn't ever mess with the length, but it goes around the width and the height. Just to clarify, this length is actually here, from there to there. Okay, so my question is, if I have this package where the ribbon, the blue part here, is 24 inches, and it goes around the package, and I could tell you a few things. The height is twice the width, and the length is 3 times the width. I'd like you to write me the volume in terms of, in other words, it'll only have widths in it. Write me the volume in terms of width. And using the 24, you could even go further and tell me what are the dimensions. To start with, whenever you're doing a problem like this, you got to draw a picture of it, and then you got to replace these labels with stuff that you know from what they told you, like this. Do you get then I'm going to replace my length with what? 3, not X. 3 W's. Because of that. How about this one? What does that replace? The height gets replaced with 2W. Get how it's W and 2W and 3W now? So the volume, here's the pure form of the formula. Always start with that. And you stick in what we know. The length's 3W. Width is W. Height is 2W. Put it all together. 6W to the third is your width in terms, or sorry, your volume in terms of width. Who had 6W to the third? Okay, good. And this last part, what are the dimensions? We haven't used the 24 yet. Let's use that. Would you agree that the perimeter around this box, going around the way the ribbon is going, would be 2 of these, which are W's, and 2 of these. Wait a minute, these are 2 W's, sorry. And 2 of these. So we called that originally width and height. 2 widths plus 2 heights. Notice me doing it as a pure form of the formula. Then I'm going to stick in what I know. In this case, I know that the perimeter is 24. 2 widths is 2, and width is actually W, so that one's easy. But the heights aren't heights anymore. They're 2 times what? I'm getting there. 2 times 2W. What I'm saying? 2 is still here. And the height is 2W. That makes it 24 equals 2W plus 4W. And that means 24 equals 6W. So what's got W got to equal? 4. Does that mean it's 4 all the way around? No, that wouldn't add up to 24. Why not? Because these sides are supposed to be twice as long, so these are 4, but the other ones are 8. So the dimensions would be 4 by 8 by, what's this? 3W, and therefore 3 times 4, and therefore 12. So 4 by 8 by 12. All right, that's pretty intense. So today, all we did on the lab was just get your measurements, and you can do some grinding out of the numbers and start looking at that ratio to try to maximize. Then, your homework for tonight is problems like this, and I'm going to show you which exact ones I want you to do. Here, you may skip number 18, the last one. But these, you start by finding the zeros, whatever makes the top 0, and the undefined things, whatever makes the bottom 0. There's nothing that makes the bottom of this 0, only the top. So I only have to worry about the top, and what makes the top 0? Could you put that on my desk? Thank you. 1/3. And does 1/3 itself work? You stick it in and you find out that the whole thing becomes 0. Is 0 less than 1? Yes, so it worked. And then you test spots around it. Something bigger than 1/3, something less than 1/3. You test around it and you see where you should shade. This one is a little unusual. So it shades, yeah, just figure out where it works and where it doesn't by plugging in bigger things than 1/3 and things that are less than 1/3. That's one major topic that you have to know. Then here, a typical word question. I feel like this one's a little unnecessary, so cross off that one. All I want you to do is that top one. Sally is Skippy's neighbor. She wants to plant a vegetable garden. Strongly recommend doing that problem. It's a great one for practice. Then this one, these are those kind where you write it as like F equals M times K. And K would be the constant, and then the F equals MA constant. I think that the acceleration is the speed of light, so it's like F equals MA. It's just that we change the K to an A, or A to a K. Anyway, that kind of answer is what you're looking for. Or if it's inversely proportional, it'll be something like Q equals K over R. That kind of equation for inversely proportional. So all you have to do is the first three, so you can skip the last three. And that makes it doable size. That's it for today's stuff and your homework. I strongly encourage you to get it in. I haven't put in homework in a while, so tomorrow I'm pretty sure I'm going to have time because this is just a review day. So we'll probably get the some homework scores tomorrow. That's all I got for you for today.